Hello students, in this video I am going to discuss that how to find the gradient of a scalar field. If I will talk about two-dimensional approach, a scalar field is defined as fxy, and if I will talk about three-dimensional approach, a scalar field is defined by fxyz. There exists one operator which is pronounced as del and denoted by this particular symbol. In two-dimensional approach, this del is defined as I cap partial by partial x plus j cap partial by partial y. And if I will define it for three-dimensional approach, this del is I cap partial by partial x plus j cap partial by partial y plus k cap partial by partial z. Now, how to define the gradient of a scalar field? So, gradient of a scalar field is just written like grad of f, and it is defined del of f. Del is an operator, so I can fix this value here. I cap partial by partial x plus j cap partial by partial y. This is all about the two-dimensional approach of f. Or I can write it I cap partial f by partial x plus j cap partial f by partial y. So this is the formula of gradient of f in two-dimensional aspect. Similarly, I can define the gradient of f in three-dimensional approach, that is also del of f, and I will be putting the value of del here. I cap partial by partial x plus j cap partial by partial y plus k cap partial by partial z of f, or it may be written as I partial I cap actually partial f by partial x plus j cap partial f by partial y plus k cap partial f by partial z. It is gradient of f in three-dimensional approach. So here is one observation regarding the gradient, and the observation is like we will apply the gradient over a scalar field. We will apply the gradient upon the scalar field, and outcome will be a vector point function. Outcome will be a vector point function. As we can observe here, I have applied gradient over a scalar field and the outcome is vector point function. Similarly here, I have applied gradient upon a scalar field and outcome is a vector point function. So this is one interesting observation regarding the gradient. Now I would like to discuss few questions of gradient of any scalar field at some point. So first question is like this. It is like fxy is provided as y square minus 4xy, and question is find gradient of f at the point, and the point is given like 1, 2. At this particular point I would like to discuss the gradient. So how to solve this particular question? As we know now, gradient of f is del of f. It is in two dimension, that is why this point is given like x and y. So what is the formula? Formula is I cap partial f by partial x plus j cap partial f by partial y. So f is given here y square minus 4xy. So here what will be the value of partial f by partial x? That is minus 4y. And what is the value of partial f by partial y? That is 2y minus 4x. But I want to know the gradient of this function at the given point. So here what I can do, gradient of f, I can just put these values, this value and this value here at this place. So it is I cap into minus 4y plus j cap into this one 2y minus 4x. But in our question we have to find the gradient at some point, and the point is 1 comma 2. 1 comma 2 means x is 1, here 2 is y in this regard. So how to find the gradient of f at the point 1 comma 2? So it is I cap, it is also j cap. So I am utilizing the value here, I cap minus 4 into 2 plus j cap 2 into 2 minus 4 into 1. 4 into 1. So that is minus 8 I cap and plus j cap here. It is like 4 minus 4. So ultimately the answer will be here like minus 8 I cap. So what is the final representation of it? Gradient of this scalar field, gradient of this scalar field at point 1 comma 2 is minus 8 I cap. So this was the first example of gradient, and this is our final answer. Now if we will observe, this first question was given regarding two-dimensional approach. What if I want to discuss one more question that is given in three-dimensional approach? So let f x y z is x square y square plus x y square minus z square, and question is like find gradient of this particular function f at point, and point is given like 3, 1 and 1. So how to solve this particular question? In three-dimensional approach we are having the formula of gradient of f is del of f. So as we know here it is I cap partial f by partial x plus j cap partial f by partial y plus k cap partial f by partial z. So here separately I will be getting all these partial derivatives. So if I say f is given as x square y square plus xy square minus z square. So what is partial f by partial x? It is 2xy square plus y square. What is partial f by partial y? That is 2x square y plus 2xy. What is partial f by partial z? Partial f by partial z, that is just minus 2z. Now I want to get this gradient of f at the given point P. I can also write it I cap partial f by partial x at the given point P plus j cap partial f by partial y at given point P plus k cap partial f by partial z at given point So what we can understand here, we can understand it like this. Here partial f by partial f by partial x at point P means partial f by partial x at 3 1 1. So how to evaluate it? This is partial f by partial x. It means it is 2xy square plus y square at 3 1 and 1. So just it is x, this is y, this is z. So 2 into 3 into 1 square and plus 1 square. Ultimately it is just 6 plus 1, that is 7. Now thereafter I would like to discuss the value of partial f by partial y at the given point P. It means partial f by partial y at the point 3 1 and 1. So what is partial f by partial y? It is already evaluated, this one at the point 3 1 and 1. So it is x, y and z. I will be putting it here. So it is what? It is just 2 into 3 square into 1 plus 2 into 3 into 1, that is 2 into 9 and plus 6, that is 18 plus 6, which is equal to 24. Thereafter I am interested in getting partial f by partial z at the given point P. So partial f by partial z at given point P is just at the given point 3 1 and 1. So what is partial f by partial z? That is minus 2z at 3 1 and 1. So it is again x, y and z. So minus 2 into 1, that is equal to minus 2. So I am having all the required values here, like partial f by partial x at the given point is 7, partial f by partial y at the given point is 24, partial f by partial z at the given point is minus 2. So now what we can do here? We can just replace all these values in this particular equation. Suppose it is equation number, suppose it is an equation number 1. So putting all these values here, it is first value is here 7 I cap into 7, or I can write 7 I cap. It was equal to 24. So j cap into 24 means here 24 j cap, and here k cap into minus 2 is equal to just I can write here minus 2 into k cap, and this is equal to gradient of f at the desired point. So students, in this particular video, what I have discussed the formula of gradient which is applied over a scalar field, and thereafter I have discussed two questions of gradient, where first question was related to two-dimensional approach and the second question was related to three-dimensional approach. Thank you so much for watching this video.